Good morning, guys. Welcome to SAP ABAP sessions. Today's session going to be 163 and 64. Two sessions will continue. Uh, quick revision from the beginning. So we have done the introduction part, then architecture, dictionary, programming. In the programming, first programming basics are over. Now we are into the complex data objects. Okay? Complex data objects. That is first half structure over. Now we are discussing internal tables topic. This is the topic. As I said, it's very important as well. So initial first introduction, purpose, use cases topic only we discussed for around 4 hours. Then after slowly started the practicals. So now if you are following my series of this classes sessions videos, by this time you are familiar with all the 12 operations, right? Now, if you look at, you have to know first basically yeah, all the operations we can demonstrate with our own data only. That is your JVK underscore program underscore internal tables. Okay, tables actually propose internal tables 1 and 2. Total these three programs, correct? Let us take first one is based on, if you closely observe what are my, because finally clarity is required rather than confusion. So this is very simple and straight how to work with our own data. Ravi Kiran Reddy records our own data. So that's why I did not use select here, append and insert through I filled it. Even I can go for all read statement, loop statement, collect, modify and delete other step. Okay, all other yesterday's clear, refresh, free also we can demonstrate, but that's same as it is. So because you should not confuse, that's why initially I introduced this first. Later go back. Second, because most of the time we work with the database tables data, that is the reason I demonstrated select query through. So the difference is here we are fetching vendor master data from the day one, we are using LFA1 data. Sub RC check, impact of sub RC and loop through. This is the basic program, declaring, fetching and displaying. Then next, how do, if these declarations or select query sequence goes in a mismatch order, you can go for into corresponding fields also. So this program is only to tell you there are two things to discuss. First, the internal table fields can be declared with English names or German field names, anything okay. And the sequence can be as per standard sequence, otherwise your own sequence. If it is your own sequence, you have to use into corresponding. Otherwise, not required. So this is only the basic understanding. Okay. Now, 1 minute. Yes. Okay. So you have to be more clear while practicing, while understanding, because today onwards we are going little ahead so that I'm revising that thing so that you should not get disturbed. We should not consider as a overload or deviation or confusion, nothing. Suppose like this is the same syntax continued, select query continued, only all the 12 operations are over. Correct? All the 12 operations with clear differences above below comparison through append, ins- insert, read statement, loop statement, sort statement, modify statement, and collect, delete, delete adjacent duplicates, yesterday's topic. Clear, refresh, free, impact. Actually, I will tell you this going forward, you will get much more clarity on the clear, refresh, free. I'll tell you. So, how to check logical query is initial, is not initial. So, if not, is not, both. Second, describe syntax also. So, describe is not new for you. If you are from BTech or MCA background, describe is there in normal SQL also. Because if you have a table, if you write a select query on table, you'll get data. You write only describe, describes the table structure. So here table properties or table attributes we are describing. What are the three? How many rows, how many lines, what are the initial memory allocated, what type of internal table it is. Right. Next, how to create second internal table based on the existing internal table. Right. This is, you have to understand one thing. The iTab 2, why we are using like, because here, mm, like because uh, I want to create the second internal table also with the same fields, with the same columns of the exist. That's why I used like. Like means a copy of the like is act like a referring to the existing internal table. So same fields through it gets created. Internal table also, work area also gets created in that way. Right? Yes, this is the way you have to understand. Simply, just like data N1, N2 like N1. N1 already declared. So this is the model. Two objects with separate name, it is created. Now you can move the data from source to target, target to source. Either way. You can use independent move statement also. Otherwise, directly move corresponding also. Okay. Independent move source to target. Four move statements you can write rather than single move corresponding you can write it. So after that, if you want to print itab 2, yes, this is your itab 2 content, right? Yesterday, I introduced one more concept that is called as append lines of. Yes, do you remember? Appending several lines or rows, right? So if you want to write appending, suppose again going back to my uh, this 1 second, yeah, this picture, like yes, this one. Hmm. So this is source itab and work area. This is target itab and work area, isn't it? So if you want to move the data, all are same structure, same column, same field names. Only the four data objects with four memory structures, four memory areas, right? If you want to move the data from one to another, you can use directly table to table through you can move. Otherwise, even work area through also we can move. Because you don't get any compatibility issues, all are created with same this thing. See, you have to go for, suppose I tab 2 you want to declare with separate field name, separate column, suppose. Then this syntax doesn't work. This is only to create a replica or duplication of that. Okay, that is the difference. So go back to our how do you use append? So simple append is used to, general append does what? It is used to move the data, append or adding at the end. Append lines of, see, append space lines space half space source internal table from followed by source index 2 followed by target index. That is, this is lower limit, this is upper limit, 2 followed by target internal table. Suppose if I execute it here, what are the rows? Right. This is source internal table content 1 to 7. This is target internal table content 1 to 7. Right. Now you want to see right statement. So, yes, like result of append lines, appending lines. Okay. That is result of appending lines in I, that is your I tab 2, because yes, this is your I tab. So first we will see append a append lines of source internal table name is lit underscore lfa1 underscore lfa1 from 3 to 5 to target internal table I tab. Simple. So this is your syntax. Appending, you can append 3 to 3, 3 to 4, 3 to 5, or that depends. So now you want to see display the, yes, this content uline again. Yes, uline will try to print the internal table content. Okay, I tab to content again, right? I tab to content, but this is your, yes, what, yes. So first, this is original database table data. 2 records appended, 2 records inserted. As a result, we got 7 at this source internal table. Target also 7. But what exactly append lines? Append lines is nothing but, so from 3 to 5, this is the source internal table. So it goes to 3, 4, 5. That is 3 means this Vary, Engineer, Bridgestone and JK. These 3 records simply adding at the I tab 2 at the last. I tab 2 at the last. See, total 7. 7 plus 3, it is going to be 10. So simply what append does? Append is nothing but simply without interrupting the existing internal table entries, simply adding at the bottom, adding at the row, adding at the last is called as appending. But simple append works on single I tab. Append lines is used to between one I tab to another I tab. You can use append lines of, okay, append lines of internal table. Correct. So again, if you go with this one, see here. Sorry. Suppose here it is. Assume that we have a, as usual, 1 to 7 records are there here. 1, 2, 3, 4, 5, 6, and 7. right? 1 to 7. This is 7. So we go to above to group 1. Okay. So that is source and target tables content is equal now, correct? But after that, I want to do append. Append means, yes, it goes to 3, 4, 5. These three records are going to add at the end. After 7, 8, 9th, 10th position, these three values will be moved. The two I told you, right? Nothing is permanent, everything is temporary only. Okay, when you execute, it happens. This is your appending lines. So, same way, we can go for Control C and copy, comment it. Let's go to the insert lines of. So, insert lines of is also used between insert lines of. So, here insert lines of in source internal table from 2 you have to write into target internal table. The difference is this, and you have to specify the index position where you want to insert it. I want to insert at 8th position. I appending is commented it out, so to avoid confusion. What is the meaning of insert? Suppose same like 3 to 5, I want to insert at 8th position, but the available records are at you cannot insert at we will insert at some 6th position, so that these three records are going to insert it. So you can find the result here like this: 1 to 7, 1 to 7. Now we will take 3, 4, 5. These three records we are going to insert at 6th position. 6th means earlier MRF goes to MRF and Apollo goes to the next level. Yes, MRF and Apollo goes to the next level. So 6, 7, 8. 6, 7, 8 is the inserted records. So overall 7 plus 3 equals to 10. Correct? So this is your overall insert lines of. Only insert I demonstrated on single internal table. Now insert space lines space off space source internal table from source index to target index into followed by target internal table, index followed by index number. Insert must followed by index. This is already being discussed. So hope you guys are clear with this. This is very simple and easy also. Yes, this is about all about overall internal tables related. How to create internal table, most commonly used syntax without a header line type through with the required columns of the table only. That's why I more emphasized on this particular area. Yes, these are all additional topics of that. How to create second one and how to copy and all. Right. Then, so we'll comment all. Later you can copy my program or write it down our program. Yes. Right. I'm going back to normal so that it will print the basic append and insert lines. Okay. So what exactly today's agenda then? Today's agenda is like we will go to another uh, this session and the next session we'll discuss the different types of syntaxes part and all. Right. So suppose right, syntax of internal table like This is a some small topic because it's a kind of second take this fine. No? Right, it's okay. No worries. We will continue with this small this thing like because that is one set of discussion is over. We are moving ahead with yes, syntaxes. So syntax to declare internal table because work areas is very simple. How to declare internal table? First data followed by internal table name, isn't it? Yes, this is your internal table, correct? So now internal table is nothing but your IT or LT or GT, that depends. Local internal table LT, global internal table GT. Okay. Yes, depends. GWA, GIT underscore. That depends on the naming conventions you have to ready to follow. Right. So we will call it as simply ITAB. That is the name of the internal table. So now type, okay, type type followed by like generally table type, then table of followed by line type followed by key type. This is the overall key type. Then initial size followed by the memory parameter. So this is a general syntax of internal table. Right. So now we will go to data internal table type. Observe it. Type table type. Table type can be three type: standard, sorted, and hashed. So standard table of the line type, let it be as it is above line type, types colon, we will write it. Standard table always uses with the non-unique non-unique key. Non-unique key followed by that non-unique key field name. Then initial size 0. Right. This is one syntax. If you go for data, one more data internal table type, I want to declare sorted. Suppose sorted table of internal table line type with sorted support both unique key field name, initial size 0. Second data is itab type sorted table of sorted table of line type with the non-unique non-unique key with non-unique key field name, initial size 0. Right. Because sorted support unique non-unique keys. Then last data uh, internal table type internal table type hashed table of line type. Okay. Hashed table of line type with the unique key. with the unique key, right? Hash table of with unique key. So this is your key field. Yes, right. Initial size. Because internal tables classified as three types: standard, sorted, and hashed. But most of the time, we work with standard index table only, almost 90% in our programs. But very rarely, here and there, you come across sorted and hashed syntaxes also. So you should not get confused how, yes, sorted, because I told you the requirement clearly. When we go for sorted is if the internal table, mm, the internal table to be created, internal table to be created in a sorted order. By default, while creating itself, you can create it a sorted order. At that time only, sorted index can be created. Yes, by default. Okay, and hashed is used to hold the to work with large quantity of data, large amount of data. Correct? Yes, this. So this is your overall. Like actually, if you look at among this, what is optional? Specifying this table type is optional. That is, if you don't specify table type, that is standard. Even we have not written standard sorted hashed till now. That is because system consider by default it is as a standard only. And when you write standard, data is must, itab is must, type is must. This table type is optional. If you want, if you don't write anything, default standard it will take. Sorted and hashed you want to write explicitly. Table of is must, line type is must. Key type is relevant to the what kind of table type. If it is standard, it must followed by non-unique key. This is also optional. If you don't specify by default, it will take non-unique key. But sorted, you have to explicitly type because sorted support both unique, non-unique. Nothing is default. You have to specify. Hashed, you have to must type explicitly unique key. Yes, these two. Initial size also important. Initial size memory is also important. Yes. So for a moment, I will discuss for 2 minutes initial size factor. Yes. What is the meaning of that? Like, yes, because this is very, very important discussion with respect to internal table. Yes. Like initial size addition is used to allocate allocate memory to the internal table. That is, so it is optional addition. It is not mandatory, it is optional addition. So by default, system considers system consider it as initial size 0. Initial size 0. So what is 0? So 0 is a that is 0 is a memory parameter. 0 is a memory parameter. 0 is a memory parameter. What is the impact of 0 is if it is 0, if it is 0, system allocates by default 8 KB memory. By default 8 KB memory. Once 8 KB is filled, 8 KB is filled. Next, system allocates 12 KB memory. Okay, again, even okay, once 12 KB is filled, next system allocates again 12 KB, and so on. And so on means it will continue like this. It will till 2 GB. 2 GB. So this is the model till 2 GB. That is maximum. Okay, maximum any internal table memory, maximum memory is 2 GB. Yes, maximum. That is after that, yes, after means post of that. After that, it leads to runtime error. After that, it leads to runtime error. So that is your overall concept. I repeat this with a picture wise. Suppose let's go back to our basic this thing. Suppose we are declaring internal table. This is the table, right? This table. So by default, it will allocate with this is your internal table with the yes, how much? It is 8 KB memory. Internal table with 8 KB memory. Once 8 KB is over, system allocates okay the extension as 12 okay, yes 12 KB. Once this 12 KB, that is this internal table is also have a special feature called as extension, storage extension. So it is extended like this. The capacity is extended. Yes. Again 12 KB is filled. 12 KB is filled. What happens? It will allocate another 12 KB like this. Another 12 KB and so on. So it will go up to 2 GB. So it will go up to yes, will go up to 2 GB. Yes. So this way you have to catch and understand. So for yes, okay, it will go up to finally 2 TB. Yes. So overall, if at all I want to write overall a kind of flower bracket, it will go up to 2 GB. 2 GB maximum each internal table capacity. So right, internal table yes, internal table is special feature. Internal table consists of special feature called storage extension. Okay, storage extension, that is extension or expansion. It will continue in this way. Okay, so I repeat it, like if you go to the initial size 0 by default, what will happen? First it will go to 8 KB. 8 KB means suppose just 1000 records it can accommodate. So the 1000 records, after that even another record comes, it will go for next 12 KB. gets allocated. This 12 kb rows also filled. Next, it will extend it to another 12 kb. Every iteration, each iteration, it will go with 12 kb, 12 kb, 12 kb, and so on. Okay. Yes. But finally, the max capacity will be 2 GB. You know, GB means gigabytes, KB means kilobytes, you know, MB means megabyte, you know, all these things, memory parameters. 2 GB, you know, our flash drive, memory cards, or our, what is that? Yeah, uh, our pen drives, 2 GB, 4 GB, you know how much memory we can carry by using 2 GB, 4 GB, 10, 20 GB, and all that. So these many records it will allocate. It will go for, yes, this is your, the case of, this is your initial, initial size 0, initial size 0, this is the approach. But we can also specify initial size non-zero. Suppose initial size 10. What is the meaning of initial size 10? I can write initial size 5, 10, 100 and all. I can write it. No problem. That is, so what exactly the advantage or limitation of this and that, you have to know the difference. If you do not specify anything explicitly, system allocates, system takes care of the memory part automatically. It will go implicit, it will extend as per the records are coming in, entries are coming in. It will manage the load like this, memory like this, implicit memory. You can check it out under memory analysis also, this all those stuff. But if I go to the initial size memory, initial size non-zero, if that is the case, see, it will allocate only to hold 10 records because you specified clearly 10 records. Yes, go for 10 records. Seconds, one 10 records is over, then next time it will again allocate memory to, again allocate memory uh, to hold another 10 records. It will allocate memory to hold another 10 records, right? So each time, yes, it will go to 10, 10, 10 records, 10 records, 10 records, and so on. So, but what is the maximum? Maximum always 2 GB only. Max, only minimum you can control. Maximum is SAP fixed. Yes. This is also overall, it is overall, it is also 2 GB only, no doubt about it. Only then what is the difference between left and right is, it is actually, this is not KBs, directly it is, we are holding 10 records. When 10 records comes, the memory allocated to hold 10 records. When 11 record comes, so it will allocate 11 to 20 records, another 10, 21 to 30, 31 to 40, 41 to 50, and so on. It will go up to, so each iteration it will allocate space to hold the another 10 records. So now another 10 records, another 10 records. Hope you guys are clear with me and understanding this. Right, 10 records. Right. Okay, I repeat, final discussion for this. So whether to choose 0 or non-zero, what is recommended case? Like, so conclusion, initial size. Initial size. Initial means first level. Size means how much size you want to allocate. Suppose, yes, what is the final statement is, if, okay, if you don't know the number of records expected into internal table, then Just don't specify anything. Let the system allocates, let the system takes care about this memory part. Okay. So you leave it as size 0 only. That is implicit by default. System takes care of the memory extension expansion. But on other side, no, I don't want to waste the system memory. Memory is a important source of the, yes, uh, system, overall system. That's why resource, right? Memory is a important resource. So that's why what you can do is you know the expected records. How many records are expected into internal table? At that time, you can go for non-zero value also. So non-zero, that is even though I don't want to waste 8 KB by default. I am restricting up to my own way, my own style, my own approach. Yes. So that's why this is system way of extension or expansion model up to 2 GB. But this is when you restrict as initial size 10, every time system allocates to hold memory for 10 records. Yes, this is the way. If the records are below 10, suppose, then there is no question of extension and expansion. It is enough. Okay. Yes, this is about your overall uh, concept. So you want to control, if you know the number of records expected internal table, you want to control the memory, then you go with non-zero value. Otherwise, let the system, you want to leave this option to the system, leave it as 0, then let the system takes care about the initial memory part. Hope you are clear with this. Okay. Yes. The last statement also I'll type it here so that we don't miss any discussion with respect to this. Even we can specify non-zero value also, okay, value for initial size, this is also a kind of parameter. Initial size parameter. Initial is a keyword, size is a keyword, followed by that m value should be memory. It should be positive integer value. You have to give initial size 0, otherwise 1 2 3 4 5 6 10, like that you can give. Yes, parameter. Okay, non-zero value. Yes. Okay. What is the case? If we are aware of expected records, records are entries into internal table, and we want to control the memory of internal table. At that time only you go for this. This is a small discussion, one time discussion. Yes, which can be applicable for with header line, without header line, same concept. Initial size right? Done. Now we will go back to this. Like whatever the internal table scenario is done. Yes, first let me log in again. I can take you to this. So you have to know the quickly the difference between standard and sorted and hashed. Suppose this is at the top, I told you standard index internal table. Standard index in the sense, actually we have not specified anywhere standard, but if you want, you can specify it as a standard also. Before going to that, what I will try to do is go back, just copy this program to internal table 3. Internal table 3. Yes, simple. That is internal table 3 is also okay. Yes, or else we can go to, if this is getting confused, We can write I tab sorted. Sorted means this explore is on sorted index internal table. Right, sorted. Yes. Okay. So first of all, standard index is over. Right. We will go and write it. This is okay. Yes, it is sorted index in sorted index internal table. So this is your purpose. So this is also quickly I don't want to go with the only changes. What are all the changes? How it behaves without header line syntax only, SAP table data only. Yes. Now one by one we will discuss. Right. So first of all, in case of sorted, how does it works? Internal table, LFA1 case only we will go. I don't want to disturb other table. Only here sorted table of, right. When you go to the sorted table, yes, you have to specify with with unique with unique key or with non-unique key. With non-unique key, we will take it. Non-unique key, you can go for land one. Non-unique key land initial size 0. So this is complete full-fledged syntax. Yes. So now, yes, this is what in earlier case standard support only unique key that we have not specified. If you want, can go back to our back program, that is internal table 2 ZAVK underscore internal table 2. This is, I am telling it as a standard, right? So this is actually the simplified syntax, you know, simplified syntax. Why we need simplified syntax? You have to know simplified syntax, right? Right. What is the complete syntax then? Because you have to know the complete syntax. It goes like this. Yes. What is the difference? Is first data same, data colon, data colon. Now IT underscore LFA1 type is a keyword. Standard table of above line type. Standard table of above line type TY underscore LFA1 standard table. Second, what next? Inter TY LFA1 next with the non-unique key. With the non-unique key, yes. With the non-unique key, land one. Okay. With the non-unique key, land one, and as well as initial size 0. Initial size 0. That's it. So this is the syntax, right? This is already declared, right? So it's already declared means you have to go with 2 times we cannot. So we will make it as 2 things separate. Yes, I will keep it period here. Work area we will create it the separate data statement so that no confusion. Correct? Work area separate. No. Yes. Done. So you have to know the close difference. You want to go with complete syntax, result is same. Complete syntax, that is by default we worked on this only. Yes. So the result is you can check all operations. Okay, all operations you can check. Complete all 12 operations you can check it out. That is your standard table, right? Yes. So only key based, because here it is standard support index based and key based. That's why even though you can work with below syntax. See, now why we require a simplified or shorter syntax, we call it as. So simplified shorter syntax. Suppose data, internal table name same, type same. Standard you can remove it. That is implicit. Okay. Table of is there as it is. TYKNA1, TYLFA1 is there. And this everything is optional, because if it is a standard, by default it uses non-unique key, that is implicit. Standard uses initial size 0 by default. Right. So that's why we always, rather than typing all these lengthy syntaxes, simply we will go with shorter syntax. So you should not get confused. Okay. But there is no shorter syntax for sorted and hashed. That we will talk in a separate program. And moreover, standard support. See, initial size 10 also you can give. Still, output remain the same. You don't get any this thing. That is zero or non-zero, it's okay. Right. Second, but here very important thing is this. Standard always use non-unique. If standard through, if I try to give unique, that is always gives error. This is the error. Standard, yes. Unique key only specified with the table category as either hashed or sorted. This is the most important. Got it? Yes. So always we have to go non with non-unique with a non-unique key, non-unique key. Yes, land one. Non-unique key, land one only. You have to see that. Okay. Yes. So this is about your overall. Even though you can you find any difference in India, then US, UK, US, UK. That is, this is the normal way append insert works, right? Okay. As it is, remaining things. So I'm coming out. Either you continue with a full-fledged syntax or shorter syntax. Generally, we'll go with shorter syntax. Okay. I'm going coming to the sorted. How does the syntaxes varies in case of I tab with sorted, and we'll go with the hashed also. Yes. So I don't type anything to you, anything in front of us. Already we took a copy, we'll quickly change it and check it out how this behavior changes. So now I explicitly specified here as a sorted. Sorted support unique, non-unique. If you write unique key, you have to write key field listener. If you write non-unique key, you can write land one, name one, postal code, anything. Initial size is up to you. There is no shorter syntax for this. Okay. Yes. This is your, yes. Select query remains same. Okay. If you want to test loop operation, say tab x through, you can check it. But you have to find the difference. There is a difference. Yes, this is error while changing, yes, inserting, because we have to comment all the code. Yes, we will go for, because these clarification purpose only. I just want to show it to you everything. So let us comment the remaining code, complete code. Complete code to avoid confusions and all. Right. So almost see, It is 500 lines code. I typed it in front of you. 500 lines. But actually, it seems like 500. This is very simple for us because it's not introduced on single day, correct? Slowly, topic by topic, operation by operation, statement by statement, I introduced it. So individually, independently, you have to practice. First, number one, we'll go with normal loop scenario. Yes, printing or displaying all records by using loop and loop. By using loop and loop. Yes. So now observe it. You have to observe. Yes, this is India only because here you cannot find difference. But if there are some other countries are there, the internal table while creating itself, it is created in a sorted order based on this land one. That's the difference comparing with the previous and because this internal table by default arrange the entries in a sorted manner. That is the advantage. Yes. Second, we'll move on to the next level. Okay, Sabarsi check is okay. You can do that. That is not a issue. Yes. Because only variations, only I will talk. So here if must end with end if. Yes, this type of errors you have to take care. Yes. Okay. Right. Then go to the U line. Reading index matching records. So yes, this is now we'll go with this one. Yes. Reading index matching records. I want to read 2 to 3 because then print the entries. So this is very simple. Yes, 2 to 3 printed as it is, no changes at all. Loop with index, it remains same. There are several variations we already discussed. If you go to remember, it's a kind of revision for you. Yes, but we have to be uncomment with carefully. Yes, how you explore also very important. Yes, otherwise this leads to confusion. Even this comment lines you have to keep it first. Yes, this all these things works as it is. If you go to the equals to, okay, you know loop followed by index or where only you will get a loop at what is that listener equals to 1001. That is the purpose. So 1 second here the confusion is one more underline is required, otherwise what you need to do is once you are testing this you have to comment this, right? Otherwise it leads to confusion. Yes, this is the advantage come limitation. You have to be more careful while testing. So it's very simple because I know I typed it. That's why I'm going back to quickly what are the things and all. Correct? Yes. So this is your yes particular record we are reading. Yes. So same quickly you can test others also. All these things will work. I think these are all time waste for us. You can try out because it will work. No need to go much depth on this, right? So right, because it will work as it is condition, all those between and all. There is no impact on the sorted case also. Right. We go with read operation now. How does the read differs? So read, okay. We will go to read. Success fail cases we'll discuss. Right. Mm. So if you want to read it, first you have to know the total records. Yes, 1 to 3, read operation, read index matching record. 2, right? See where, yes, after this thing we are printing, then again, yes, so read with index 0 fail, index 4 fail, all these styles you can try out. Okay, that is same. So go back to the second session.